In this example, we're being asked to calculate our equilibrium concentrations. So first thing, we write our balanced chemical equation just like we did before. And then we're going to do our ICE table where we write our initial, our change in concentration, and our equilibrium concentration. So now we are given our initial concentrations of our two reactants, but we weren't given any for our product. So we would assume it's 0. We know some reactant will be consumed to form product, and we're going to have, for each 1 mole of nitrogen that reacts, 1 mole of C2H2 will react to form 2 moles of our HCN. So then we can add our change line with our initial and we'll get our equilibrium concentrations. After that, we'll write out our equilibrium expression and we can substitute in our concentrations. And then this will allow us to solve for our value of x. So we can now factor the equation and gather our like terms. And what we'll find is that we're going to end up with a quadratic expression that we'll have to solve. Okay, so once we have our quadratic expression, we can then solve using the equation negative b plus or minus b squared over 4a divided square root divided by 2a, and we'll get two values of x. And so what we'll see is one of our values of x is negative, and since we cannot have a negative concentration, we can reject that value. We can then take the value of our x and substitute it into the E line for each of our entities to solve for their equilibrium concentration.